Okay, today we're going to start our lessons on probability. And the lesson that we're going to talk about today is not exactly probability, but it is a way that we can count the amount of outcomes, which is what we need to do it in order to find the favorable outcomes that we use in probability. So it's sort of like the lesson that comes before the actual lesson on probability. So today we're just going to ask ourselves, how can we count the possible outcomes of a given situation? So we're covering the Integrated Algebra Statistics Standard 19. Even though it's statistics, it's like statistics and probability. So determine the number of events in a sample space and the number of favorable events, okay? So a sample space is what we call, is what we need for probability. Probability is the number of favorable outcomes over the total possible outcomes that could happen. So here we're going to learn how to count all the total possible outcomes that could happen, and then in tomorrow's lesson we're going to talk about how we could get the ones that we consider favorable. Okay, so our vocabulary today is tree diagram and counting principle. Now let's say that we have a situation where a store offers 5 flavors of ice cream: vanilla, chocolate, strawberry, and peach, and raspberry. A sundae can be made up of either a hot fudge topping or marshmallow topping. If a sundae consists of 1 flavor of ice cream and 1 topping, how many different sundaes are possible? So there's a couple of different things that you could be asked to do on the regions. You could be asked to list out all the possible outcomes, in which case you can do them with these 2 methods. Or you could someone could ask you all the possible, they could just ask you the number of possible sundaes that could be made. So this question is asking how many different types of sundaes can be made, but I'm going to ask this question as a precursor. List all possible sundaes. Okay, so a sundae consists of 1 flavor of ice cream and 1 topping. So let's talk about the tree diagram first. The tree diagram is a diagram that the first branch that you do, so you have all of these, we're going to have 5 branches to begin with. The first branch on top consists of the flavors, so it's the first choice that you have to make. If you were at this ice cream parlor, they'd say, well, what flavor do you want? And you'd have to say the flavor first. So with our tree diagram, we're going to start with that. So let's represent the flavors: vanilla, chocolate, strawberry, peach, and raspberry as capital letters. Okay. Now, if I chose vanilla, I would then have 2 more choices, 1 more choice I could make: hot fudge or marshmallow. So from vanilla, if I were in the first branch, I could choose hot fudge or marshmallow. Okay, so these endpoints here, there's 2 endpoints. And a tree diagram, the way that you count up all the possibilities is you think about the branches on the tree. So here I have 2 possibilities that 2 possible sundaes. I have the vanilla ice cream and the hot fudge ice cream, or the hot fudge topping, and I have the vanilla and the marshmallow. Okay, so each branch here represents 1 individual sundae that you could make, 1 unique sundae that you could make. Okay, I could have chosen chocolate, and again I would have the choice of a hot fudge or marshmallow. Same with strawberry, same with peach, and same with raspberry. Okay, so I count the amount of outcomes by looking at the end branches here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's one way to list out. And so a few times on the regions I've seen them ask questions about outfits. Like they'll say you have a certain amount of shirts and a certain amount of pants and a certain amount of shoes. Use a tree diagram to list all the possible outcomes. So you would want to list your first choices in the first row, and then from each first choice you want to make a branch for however many choices you have in the second row. Now you could layer this on. Like let's say that you had the choice of either having the rainbow sprinkles or nuts. So from each of these, you could have rainbow sprinkled or nuts, rainbow sprinkles or nuts, and then you could have another layer here, which would represent 1, 2, and then a third choice of sundae. 3 choices for your sundae. But since we only have the topping and the type of ice cream, then we only have 2 layers. We have 2 layers of our tree. Now, the second way to list something off is a list of ordered pairs. So I've actually started doing that below here. So if I wanted to list out the ordered pairs, this branch would represent the vanilla and hot fudge. So it's ordered pairs just like XY coordinates. And I actually like listing with ordered pairs a little bit better than I do with the tree diagram. So I'd have vanilla hot fudge, vanilla marshmallow. Then I could say chocolate hot fudge and chocolate marshmallow. Strawberry hot fudge. Strawberry marshmallow. Peach hot fudge and peach marshmallow, and finally raspberry hot fudge and raspberry marshmallow. Okay, so I have, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same with this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you're asked to use either a tree diagram, this is a tree diagram, and this is ordered pairs. If you're asked to use one of those to list out the possible outcomes on the regents, this is how you would do this, okay? Now, notice that they're not asking for, they might ask a follow-up question that says, like, how many outcomes can you get? And then you'd answer 10 possible Sundays for us. Okay? Okay, so that covers the tree diagram and the list of ordered pairs. Now, to answer just the number of possible outcomes and not to list them out, because sometimes listing them out could be very difficult if you have like 100 possible outcomes. You don't want to list them all out, but you just want to know how many. We're going to use something called the fundamental counting principle, or just the counting principle. If one activity can occur in M amount of ways, and a second one can occur in N amount of ways, then the number of ways they can occur together is the product of the two ways. Okay, so you had 5 ice cream choices in the example before, and you had 2 toppings to get 10 possible sundaes. Okay, so this is just an example of how we could use the counting principle to have found 10 possible sundaes. Let's say you added 2 choices of sprinkles. Oops. You could have chocolate sprinkles, or you could have rainbow. Okay, then what I would do is I'd say 5 possible ice creams times 2 possible toppings times 2 possible sprinkles, and that would get me 20 sundae choices. Okay, so this can be extended for any number of events. So I had 3 events here, and so if I added another layer to this, I could just multiply it by that possible number in order to get the new amount of sundaes. Okay, this is called the counting principle. Now let's use the counting principle to find the answer to the following questions. So the school cafeteria offers 4 types of salads, 3 types of beverages, and 5 types of desserts. So 4 types of salads, we could say 3 types of vegetables, or 3 types of beverages, and 5 types of desserts, okay? So if a lunch consists of 1 salad, 1 beverage, and 1 dessert, how many possible lunches could this be? So we want salads, how many possible salads, times how many possible beverages, times desserts. Okay, so the amount of salads is 4, the amount of beverages is 3, and then there's 5. All together, that's 12 times 5, which is 60 possible lunches. Okay, so this is just answering the question, how many possible? It's not using a listing feature in order to list out all the possible outcomes. Example number 2 is a tennis club has 15 members. There's 8 women and 7 men. How many different teams can be made with 1 woman and 1 man? Okay, again, so there's 8 women times 7 men equals 56 possible teams. Okay, and our third example is going to be that of a license plate. So let's say that a state issues a license plate consisting of letters and numbers. How many possible license plates can be issued with the following restrictions? And this is going to have three parts to it. I just have one of these parts on this page. So the first part is 2 letters followed by 3 numbers. And I'm allowed to repeat both the letters and the numbers. So what I like to do is I like to build slots. 2 letters and 3 numbers, okay? So this is a letter, a letter, a letter, and a number and a number. Now, there are 26 letters in the alphabet. So for my first choice, I have 26 letters, okay? Now, if I use a letter, I'm allowed to use it again for my second letter. So again, I have 26 possible ways of choosing the second letter. Okay, now for the third letter, again, I have 26 because I'm allowed to repeat again. Now the single digit numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's 10 possible single digit numbers. Okay, and again, I'm allowed to repeat. So this is what this is right here. Now if I use a calculator to calculate these possibilities, okay, I would get, let's see, 1,757,600 possible license plates. Okay. So if I think about that, it's like 1.7 million about. That's actually not a lot of license plates. If you assume, so let's say New York City has a population of 9 million people, and of course not everybody owns a car, and not everybody's of legal driving age, but 1.7 million license plates wouldn't even be enough to cover the amount of license plates needed for New York City, let alone New York State. So, you know, this is actually, we need more combinations. And if I think about what I want to add more, would it be better to add a letter or a number? I'd have to go with adding another letter, because if I add another letter here, let's say that I go ahead and add another letter, well, I'm going to be multiplying it by 26 as opposed to adding another number, which would only multiply it by 10. Okay, so in this case, if I wanted to get more license plates, I'd rather add another letter than number. All right, let's say that the state issues license plates that consist of 2 numbers. So I have 2 numbers, a number, and 3 letters. So I'm going to multiply all these things together when I get them. Okay, and only repetition of letters is allowed. So the numbers are not allowed to repeat. So for the first space here, I have 10 possibilities that I could use. Choosing a number, that event can happen in 10 possible ways. But choosing a second number, there's only 9 ways that I could do that, because I'm assuming that I chose a number. Choosing the first number, I have 10 options. But if I choose a second number, these are all my single digit numbers. As soon as I choose a second number, well, one of these numbers, let's say it's like 4, one of them is knocked out. Right? It could be 4, it could have been 5, or 6, or whatever it was. I chose one for the first one, so choosing a second one means that I have to knock out one of the possibilities. So there's only 9 ways to choose it, to have the event choosing the second number. Now the letters, we start again, there's 26 letters, and we're allowed to repeat the letters, so these are all 26, okay? And if I do that on a calculator, I would get, let's see, 1,581,840. And just to make a note, and I didn't make a note of this before, when I'm multiplying 26 times 26 times 26, on a calculator I put 26 to the third times 10 squared. That's just a quick way for me to do that. Now notice that the amount of license plates I could make when I'm not allowed to repeat the numbers is decreased. I can only make about 1.5 million, or actually 1,581,840, as opposed to 7,757,000. Okay. And the same went here. I had 3 letters. I have 3 letters here, and I have 2 numbers and 2 numbers here. The only difference is I'm not allowed to repeat one of the numbers. Okay, so if I were to figure out If someone were to ask you how many more license plates you can make if you allowed repetition, you could take this figure right here and subtract this figure from it. Okay. All right, let's go on to a different option. Let's say option 4 is 4 letters followed by, or 4 numbers. So 1, 2, 3, 4 numbers. These are numbers. Followed by 2 letters. But I'm not allowed to repeat anything. Okay. So the event of choosing the first number, I have 10 possibilities. There's 10 ways that can happen. Okay, and then we have 9 because I assume that I picked one on the first go. And then I have 8 possible numbers to choose from because I'm not allowed to repeat. And then I have 7 numbers to choose. The 4th number, by the time I get to the 4th number, I only have 7 left to choose from. Okay, the same goes for the letters. I start with 26 letters, but then I'm not allowed to repeat the letters, so I have 25 options left. Okay, and on my calculator, I have 3,276,000 ways to do that. And there's more ways than there were for these ones because there was only 5 things that I chose here, 2 numbers and 3 letters, whereas here I chose 6, 4 numbers and 2 letters. So even though there wasn't any repetition allowed, I'm choosing an extra, I think it was an extra number in this case. Okay. Okay, let's say that a bag consists of 4 marbles, 4 yellow marbles, 3 red marbles, and 2 blue marbles. If all the marbles are drawn out of the bag one by one, how many possible ways can this happen? So the way that we do this is we think about, okay, and let's further say that each of these colored marbles have a number on it. So like the yellow marbles would be, you have 4 yellows. So it'd be yellow 1, yellow 2, yellow 3, yellow 4. Okay, and each of the red marbles has red 1, red 2, red 3, and there's 2 blue, and there's blue 1 and blue 2. Okay, the reason why I'm putting numbers on them is because it makes them unique. If they aren't unique, like if you have 4 identical yellow marbles and 3 identical red marbles and 2 identical blue marbles, then it's much more difficult to do this problem because you're going to have to divide by something in order to get rid of what we call repetition. If you have 4 identical yellow marbles, then you're not going to be able to tell if you pulled out yellow 1, yellow 2, yellow 3, or yellow 4 first. And you will learn how to do this when you get to Algebra 2. So let's say that they're each unique and they're colored. So we have these 10 marbles. So, let's see, we have 9 marbles, right? So there's 9 choices. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 choices. Now, let's say that I pull one out, and it happens to just be like red number 1. So for the first pull, I have 9 possibilities. I could get, red 1, yellow 1, or blue 1, or red 2, or yellow 3. There's 9 possible types of marbles I could get. Okay. In fact, let's get rid of the color notations. Let's just say that I have 9 marbles that are all different. So I have 9 unique marbles. Okay, so I drew 9 marbles and I put the first 9 letters of the alphabet on it. So the first way I could choose is 9. And then let's say that I chose one. Okay, well, I picked E out. Well, I would only have 8 choices for my second one. And then for the next one, I'd have 7 choices, right? So I picked one out. Then I have 7. And then let's say I picked that one. Then I'd have 6. And let's see, I picked this one. And then 5, 4, 3, 2, and 1. Okay, this right here, 9 times 8, a number multiplied by all the numbers below it is called a factorial. So right here I have 9 factorial, and your calculator will calculate this. So I put the keystrokes below. You would first press the 9. Okay, then you go into the math menu, arrow to the left, and you would get to probability. Okay, and you choose option 4 and press enter, and that gets you the factorial. Right, and when you calculate it, the home screen is going to look like this, 9 factorial, and it gets you, let's see, 362,880 possible ways. Okay, so it seems kind of strange that that's the amount of ways that you can choose 9 unique marbles out of a bag, but it really starts to accumulate faster and faster because there's 9 you can choose from, and then 8 possible, then 7, and when you start multiplying these numbers, they just start getting bigger and bigger. 9 times 8 is already 72, so it's already getting a lot larger. All right, and so that's the end of our lesson today. You learned how to use the counting principle to figure out the number of possible outcomes for repeated events, or for many events all at the same time. So we used examples like license plates, and I showed you what a factorial was, and that's about it. And I showed you I showed you how to use the tree diagram and a list of ordered pairs in order to list out all the possible outcomes in an event space.